vital signs as we pass through the vacuum.
Change of course, affirmative, confirm, new position fixed, interpreters, proximity, execute, activate.
We go from planet to planet. Pick up the pace. There is a corridor in space. We are heading to a different system. Proceed with this assignment. One more slingshot. We'll take all the gravity you've got. Surely by now you are aware of this rare outer-planetary alignment.
Stand by for swift approach. Stabilize the gyroscope. Computer systems in control. Passing Saturn's northern pole. Precisely calculated distance. Using Saturn's thrust systems at this most advantageous speed. We can proceed.
We go from planet to planet. I must insist we make a Uranian twist. Computer, make preparations for another gravity assist. Enthrusted ship, charged in a planetary grip. Oh Neptune, send us hurtling through this liminal abyss.
Release this solar system bound for interstellar space. Kindly take up your position. Your sleeping pod awaits. They are optimized for comfort as we navigate the deep. Let your
There we go. Can you hear me when you get this? Oh, there's a 30-second delay. There we go. Sweet. Hello everyone. Right. So, how this is going to work is, if you've got any questions or anything, yeah, I'll try and work through them. I've got a little drawing device tablet thing as well, so I can, if there's anything around the stats or anything, I can kind of talk to you around those as well. So that's my plan at least. I need to raise this background noise. There we go. So yeah, so whenever you've got questions, if you type them in the chat, I'll try and get through them. Otherwise, you just hear me talking nonsense, which I guess is not so different from normal. But yeah, Happy New Year as well, by the way. Hope you had a good one. And it's okay to go first as well. I'm going to get in a more comfortable position. Why does this stop playing? There we go. Good first question. So thank you. So the question is, which graphs do we need to report for multiple regression? I can't have silence because I can't work with silence. So what graphs do we need for multiple regression? So the main reporting for the regression is really that table, right? The coefficients table. Whether you report that in text or as a table is up to you. If you want to write out every beta or anything, but I would just put the table in for the coefficients. That's kind of the number one thing for presenting your results. The graphs that I would put in are probably the correlation matrix, which I've talked to you or some of you about. That's again, if you want me to show me how to do that, let me know. I better load Jasp up actually. Let me just load that up so I can show you. To show the, just to show the correlations between the kind of the individual variables. Let me just open that up. There we go. So there's that one, it's correlation matrix. The second one is, and these can go in the appendix, so it relates to the second question really. The predicted versus actual residuals plot. The standardized residuals versus predicted plot, I should say. Let me just see if Jasp is loaded up. If I can get Jasp on, I'll show you on Jasp. Hold on. Shall we do that? That's going to be easy, isn't it? Let me just open a random data set. Regression. Adam Sandler. Okay. There's a data set called Adam Sandler apparently. Right. Blah 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 blah. Right. Let me just open this and then I'll share it on my screen. So. you will be able to hear me now. So I'll start again. Right. So so simple correlation. This is what should go in first. You can either put in the correlation. I'm 30-second delay, so it will work. I'm just responding to the comments. Just give me a thumbs up or let me know that you can hear me when it's come through. Stock music, yeah. Hopefully that's not too loud. Let me know if it's too loud. I can't work in silence, that's all. I'll turn the audio down. You got me? Can you hear me? This is well produced, isn't it, this? I'm just waiting. Sweet, all good. Right, so let me go back to JASP. So correlation table is fine by its own. I'd flag the significant correlations as well. Here, the correlation plot, that's you can do by clicking on scatter plots here. This you can put in maybe in your descriptives part of your, the start of the results. This is what the means and standard deviations were for each condition. Here's this general correlation matrix showing the relationship between all of the variables. So your outcome variable as well as your predictors. Again, just to repeat, you don't need to put age or anything in there that's not important or interesting. So we've got this correlate. You can put this in your results section or in your appendix, depending on what you want to do. One of the other things I should say is that you should always reference in text anything that's in the appendix or anything that's in your results section. Always refer to the table or the figure in the actual text. Okay. So this is what the first graphs that I put in the results section for a multiple regression. Then we could do the regression itself here. Let's just say we're looking at box office as the outcome variable. This won't be significant because the correlations are not significant. And year and freshness, whatever that means, not significant, as the predictors. So what figures do we want? So when I was talking about the coefficients table, that's this one. This is kind of the main table. You need to report R squared here, which is very low, 0.04, which is why it's not significant, and whether that model is significant or not, which is this p-value here. Okay. Let's go back here. So what do we want? You can get descriptive statistics here. You can report those in text as a table or just in prose. Do one or the other. So don't write about them and then put them in a table. Either do the table and refer to them or write them in text. We need this VIF, which tells you whether multicollinearity is not a problem. If it's less than 10, it's not a problem. As you can see, it's less than 10. What else do I want? I want plots. Again, my version is probably a little bit older than yours. So the key ones for your assumptions are residuals versus predicted, which is this figure. And what you're looking for is the distribution of the dots is the same above and below the line. They are here, so that's telling us that we have homoscedasticity. You also want to see that the residuals are normally distributed, and that is that in general, the little dots here are falling along the diagonal of this QQ plot. Now, these two plots, right, the results, residuals versus predicted, and the QQ plot here, they can go in the appendix. Do we need anything else? Don't need anything else. You could, I mean, if you wanted to, you could do histogram of the residuals. Don't really need that. What you really need is this QQ plot. So what we've got here is the three things, right, that I talk about in the lecture. We've got the descriptives, which would be the correlations, but I'd start off with the, where are they? The descriptives here. So that descriptive table, then talk about the correlations. You can put this table in as well and refer to the figure. Is the model significant? Well, the R squared is 0.04 and the model is not significant. You can put, technically you don't really need the coefficients table at that point, but I would just put it in for completeness. So by the way, you can copy the table and paste it into Word. And same with the images, by the way. If you click here and click save image, it'll save it as an image file. So then you put the coefficients, so sorry, descriptives, then the assumptions, which is that is multicollinearity a problem? No, it's not. Why? The VIF is less than 10 for both predictors. Are the residuals normally distributed? Yes. The QQ plot has the dots falling along the diagonal, roughly. Is there homoscedasticity? Yes. These dots are equally distributed above and below that red line there. Is that okay? That is everything that you need. Now, let's go back to these questions. So, in the appendices, do we need to include a link to our Qualtrics survey? No, yeah, you don't need a link to the survey. You can put the data in there if you want. It's not something that we're primarily gonna look at. Oh, you're looking at my feed now, aren't you? How should we format an appendix? I'm going to have to change this. How do we format an appendix? So yeah, with the appendix, you just, to be honest, as long as you're formatting it the same for each appendix, so appendix A, B, C, D, we just want it uniform. So just have the same level header, appendix A, and then it might be the assumptions figures, for example. So figure A1, so appendix 1. Yeah, the stream will be uploaded. Appendix A1, figure A1, residuals versus predicted for this regression. Figure A2, QQ plot of the standardized residuals, right? Then appendix B might be the data set. Appendix C might be your informed consent and stuff like that. So not fussed about the order. I just do it in a logical order. So you probably start off with like, and these aren't like these are not like going to change a grade boundary, right? This is just for completeness and probably, maybe shoving you up or down within a grade boundary. But these are not going to be reasons why you'd get a 2-1 or a 2-2. This is just for completeness and probably the higher end of the grades. Yeah, does that make sense? So probably do it in logical order, but as I said, refer to those in text as well. So if you do include your informed consent and an information sheet, when you're writing about the procedure in your method section, you just brackets appendix A or B or whatever when you're talking about those. No appendix in the word count. You'll be glad to know. Yeah. Any more questions? Can be anything. It could be stats based. It could be about the writing. It could be anything that will help you with this report. Let's go back to Jasper. Our research title, abstract references, excluded, yeah. So it's just the intro, methods, results, and discussion that fall under the word count. Yeah. So good question, Holly. It depends. So I think it's going to be slightly different if it's the ANOVA report or the regression report. I'll go with regression because we've just been talking about it. So I think in general, you're looking at 500-600 words for the intro and the discussion. So that takes you up to about 1,200 words or so. For regression, you might write a little bit more for the methods, right? Unless you're doing like a really complicated experimental design, because in the method section, you're going to be writing, I would do a subheading for each of the scales that you use in that regression design, right? So for example, a regression results section might look like, heading is method, then participants, Design, you might just sort of 1 or 2 sentences about the correlation or whatever, cross-sectional. Then materials, and then subheadings within materials. You would have a subheading for each of the scales that you've used. Now, a little tip is that for each of the scales that you've used, they should be published in general, right, that you've already published, unless you've kind of made one or made a hybrid of a scale. I would have, or Chris or someone would have talked to you about that in the session. You want to report, you know, how many questions, you know, what is that scale? How is it measured? Is it the mean? Is it the sum of the responses? Where, you know, what's it called? Where is it published? What's the original reference? What does it measure? Does it have any validity or reliability, which is Cronbach's alpha? But a little tip is go and find a paper on multiple regression that you like, right? Go and find a paper and look at the results and methods section for that. So I'd say 500-600 intro and discussion. Methods might be a little bit longer, might be for your methods, so 300-400, and maybe 200-400 for your results section. Your results section really should be the shortest section of your report in terms of words used. It's very matter of fact, right? There's no inferences based on it. What do we need to include in a rationale? Now, this goes, good question. So this is actually where we get into like the first category, first territory. So your rationale is based, it's your motivation. Another word to kind of use is motivation. So why are you doing this study? And that needs to come across right in this report. Like when we read the introduction, we need to know it's not just a dump of information, right? It's not just, oh, here's some stuff. You need to have this logical progression of ideas towards your hypotheses, right? Which are your, either your predictions around whether there'll be a relationship between any of the the predictors and the outcome variable, or if it's an experiment, what effect do you expect to see in the data? Now, if you're doing an ANOVA, the reason why you're doing an ANOVA, remember, is pretty much the interaction. That's the most important thing, right? That you, why are you putting these variables together? Why are you testing? I don't know. Let me think of a ridiculous design. If you were looking at 100-meter sprint times between people who've had caffeine and not had caffeine, and what would the second factor be? Caffeine and not caffeine, and then time of day, right? So early or evening. Why would you do? Do you expect caffeine in the morning to have a quicker time than caffeine in the evening? Do you see what I mean? Like why put those variables together? What led you to that point? So that's what we mean by rationale. Like, okay, so this is an interesting topic, blah, 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 blah. What about the literature that you reviewed in your literature review section? What led you to those hypotheses? And that's the rationale for your study. Can we use some of what we wrote in our pre-reg form? Yeah. Oh, that's actually a good question because it's a group thing. Yeah, so you can use it, but I would rewrite it. Make sure you've got your pre-reg form saved, by the way, in case you ever get any called up on it. But because of the nature of that, if you all copied and pasted the exact same thing, obviously it would flag on turn it in, right? But I would reword it. What does it mean if your correlation has an inverse relationship? So a correlation can be positive or negative, right? So a positive is that, I can show you on here, right? Yeah, here's a slightly positive relation. So as this variable goes up, well, it's not really that strong, so does this variable. So as you increase this scale, so does this scale increase. A negative correlation or negative relationship is that as one variable goes up, the other one goes down, and that's what we mean by a negative relationship. So positive, as one variable goes up, the score on another variable goes up. A negative correlation, as one variable goes up, another variable goes down. So like, for example, look at this data point here for a negative correlation. This one is a higher value on the x-axis and a lowish value on the y-axis, whereas this one up here is a smallish value on the x-axis but a high value on the y-axis. Hopefully that answers that one. So the correlation's interesting, right? Because that's a regression's a fancy correlation. So the coefficients here, where are we looking? Here, these unstandardized coefficients. A negative coefficient here would mean a negative relationship in the same way as a negative correlation, whereas a positive value here is the same as having a positive correlation. The coefficient table came out weird because of Word. It is if it doesn't look completely bonkers. Otherwise, just try and do it in your own, like type the words in. The coefficient. Can you go through this from the start, please? The JASP. Yeah, I'll do another one. I'll do a very quick one because I have done. This is recorded, so you can go back to it. Let's do open data library. Regression. Regression? Yeah? I'll do a regression again quickly, then I'll do an ANOVA. Let's have a look at this. College success, exam anxiety, fidgeting and fat gain, Glasgow norms, physical activity and BMI, president's height. Example experience. Oh, logistic regression. We don't want logistic regression. We want example use of learning. Let's do album sales. Right. Let me get rid of that one. Right. Let me get rid of these, and I'll do it from the start. Right. I'll do this one, and then I'll do an ANOVA just very quickly, so you can start and stop. Okay. So this has got, I don't know, number of adverts, the sales, how much it was played on air, and whatever attract means. Let's just do sales. Let's do how many sales from adverts and airplay. That makes sense, right? So first thing we want to do is let's have a look at the correlation between those three variables, right? Done this already, so I'm going to go through it quickly. Let's get these. Make this a bit bigger. Right. And by the way, you can drag these figures out here, look, just to make them more readable. Here we've got a very strong positive correlation right on this one. Okay, so let's do the regression and I'll go through everything. So regression, linear regression. We want to predict sales from airplay and adverts. I'm just going to everything that I need to have. We want descriptives, we want the VIF. What else do I want? I want some plots. I want the residuals versus predicted, QQ plot. That's it. I mean, I've been doing this years, right? So I'm like, boosh, boosh, boosh. Let's have a look what this means then. So first thing is descriptive statistics. So we can put that table in here. That's just the mean and standard deviation of every variable. Then I'd talk about the correlations between the variables. So we have, a significant relationship between sales and airplay and between sales and adverts, but no relationship, because this is not significant, between airplay and adverts. And you can see that here, right, that we have for sales, when airplay, there's a strong positive correlation, and for sales and adverts, there's also a positive correlation. But between airplay and adverts, this figure here, it's a flat line, right, so there's no relationship. Anyway, is the regression, so that's the descriptives. Is the regression significant? Well, the R squared value is very high, 62.9%. And this is significant, okay? So then we'd have to look at the coefficients table. What is that telling us? Well, there's a positive, because these unstandardized coefficients are positive. That's telling us there's a positive relationship between adverts and airplay and album sales. These are both significant. Remember, if your regression model is overall significant, it doesn't mean that each of your predictors is significant. We need to look at this coefficients table to see, right here, whether they are significant or not. And we can see that both are here. So that's just the general finding, right? That both predictors are significant. The next step is, okay, out of those two predictors, which is the most important, which is the strongest? And for that, we look at the standardized column. And even though these numbers are quite close, airplay, because this is just a slightly higher number, is the stronger predictor of album sales, but only just by a little bit. Then we need to look at the three assumptions. Number one, multicollinearity. There we look at the VIF, the variance inflation factor. This needs to be less than 10 for both of the predictors. It is good, that's fine. Is the property of homoscedasticity, that we look at the residuals versus predicted plot. Is there an equal distribution of the dots below and above the line? Yes, there is. So we've got that. You can say a visual inspection. A visual inspection of the QQ plot here as well reveals that the residuals are normally distributed as well, because these dots fall along the diagonal. Okay, and that's everything. So this is pretty much all you need to include in your results section, but obviously you need to write about each part. Do you need to paste every table graph? You don't need it. As I said at the start, you can rewrite to the beginning. The key ones are this one, and the correlation matrix. For regression, we'll get on to. Is anyone here need me to do ANOVA very quickly as well? Just let me know in the chat. Would we get marked down if we have a little bit of inference in the results section, only so it doesn't look like a long list of numbers? No, you don't need to explain significance of the P and the F value, right? You just say that they're significant, okay? My advice, again, have a look at a report that's used regression or ANOVA. Have a look at the results section. How is it set out, right? You won't find any explanation of, why it's significant. It's just, it was significant, it was not significant, and then the P value, okay? Is it bad if our results don't exactly match our hypothesis? No, you won't get marked down at all. In fact, you're more likely to get marked up if you point that out in your discussion and explore why they didn't match your hypotheses, right? That's the thing we're looking for. I don't care if your result is positive or not, right? I don't care if it's significant or not. What we care about is that you've gone through this process of coming up with some hypotheses, testing it, and then making a discussion around, okay, so if it was what you expected, that's good. How does that fit into the literature? If it wasn't, then why not? Okay, so you don't get marked down at all for that. Yeah, okay, ANOVA. So let's get another data set. Open data library, ANOVA. Mixed design. Let's do repeated measures. Bush took a food, whatever that is. Let's get that up. Get rid of that. Right. Get rid of all this. It's been done before. Right. So it looks like we have, what are the two? Oh, well, I didn't think I'd be talking about kangaroo testicles today, but here we are. This is just a one-way ANOVA. Oh, no. Unless, yeah, that's just a one-way ANOVA. No. We want two-way, don't we? ANOVA, mixed design. Here we go. Erotic pictures and love, no. One-way ANOVA between. That's between subjects. Response times on the street task. Let's have a look. Where was that? Well, we'll just do this one. I mean, I don't know why it's on there, but we'll just do it. Right, and I'll be able to tell just by looking at it what type of design that we have. Okay, so this is between subject, is that right? Yeah, between subjects and over. Right. Let me get rid of all this. Right. Okay, so what do we have here? With age, we've got gender, condition, how, maybe I should have read the thing. What's this? Relen. Okay, so let's just do male versus female and whether they were looking at nudes or abstract art and the outcome variable is love for partner. Let's just do that, it doesn't matter. Right, so ANOVA, so we want to come here. So a dependent variable for between subjects ANOVA, we just said it was love for our partner. The fixed factors were condition and gender. Why? Oh, I should have looked up, shouldn't I? Tells me here. Right. Okay. What do we have here? So, descriptives, effect size. Again, I'm just doing this from memory. We need homogeneity test. We need Q-plot residuals. Descriptive plot. Let's do this. Always have error bars, by the way. Standard error. Let's have a look at this. Let's see what this gives us, and I'll go through what we need. Yeah, that's all you need to know for regression. Right, ANOVA. So I can tell you straight away, nothing significant here. So, but what we'd report first is this descriptives table, or write it in text. So descriptives, assumptions. Well, what are the assumptions for ANOVA? Do we have normal distribution of of residuals, but you can look at a histogram or a Shapiro-Wilk test for each of the individual conditions. Is there homogeneity of variance? Is Levene's test not significant? It's not. That means we're okay. That means we have homogeneity of variance. Then we report the figure here. Let's make it a little bit bigger. We can have a look at it. Right. And what can we infer from this? Well, as we can see, just even looking at the p-value column, we don't have a main effect of gender. We don't have a main effect of condition. We don't have an interaction between them. And that would mean at this point we would stop. Okay? Don't need to report anything else. There was no effects. Now let's just imagine, so I don't have to go through finding all these data sets. If let's just imagine if these were all significant, what we then need to do is our post hoc tests. And to do that, we come here. We click on the interaction pretty much because the interaction is significant. We'll have to do these as well. Now, bonus question, you should be saying to me, oh, we don't need to do post hoc tests for each of the main effects. I'll give you a second to think why. Condition and gender only had 2 levels. So because they were significant in this theoretical example, that would mean that you don't have to do the post hoc test, but you do need to look at what way around the effect is. Now to do that, you need to look at the marginal means here. Okay, so for gender and condition, this is only if you have 2 levels, by the way. Let's have a look at the marginal means here. So yeah, we would be like, oh, nudes is higher than abstract art, and oh, female has a higher score than males in general. Okay, that's for the main effects. Here are those post hoc tests. They're not significant, obviously, because of this example, but that's what we need to report as well. If you have more than 2 levels, if the interaction is significant, you can put this table into Word. Again, you can copy it or put it yourself into your results section. And there we'd be able to check which of the conditions were significantly different. Actually, post hoc test, we want to do the Bonferroni. I mean, it doesn't actually matter, but let's just say to keep it in line with what we've taught you, the Bonferroni correction. We'd be looking at these p-values to see which are less than 0.05. They could all be different to each other. It could be that 1 or 2 of them are different to each other, but we need to report those. And we'd want to put in this figure for sure, because this shows you where the effect is, right? So again, descriptive statistics, assumptions, which are, is the data normally distributed? Is there homogeneity of variance? Yes, there is. what is the outcome? What is the test? Right, that's this table. Well, in this example, none of them were significant. Report each F statement. If none of them are significant, you stop there, and that's absolutely fine. You don't lose grades or marks or anything. But if they are significant, we expect to see the post hoc analysis as well. Okay? Yes, that's all you need to know for regression. Yeah. So I've done those very quickly, right, because I've been doing these years. But that's it. Again, break it down. Descriptives, the assumptions, the outcome of the tests themselves. Do you have any more questions? I'm just having a look if there's any coming by email. I'm just checking my emails quickly just to see if anyone's. Oh my god. I'll answer that one myself. In our introduction, should we critique existing literature? Should we say this evolution for our decision when we link back to... So again, I wouldn't get too bogged down on like existing or... Your introduction needs to serve one purpose. Why did you do that study? Like, what is the key literature? What's the key theory behind it all? That's what we're looking for. You know, if it gets, you know, from the general problem through to the hypotheses, that's what we want. Then in the discussion, we want, okay, what was the outcome of that experiment or survey? Or sorry, regression, ANOVA results. Does that map onto your hypotheses? If it does, great. Where does that fit into the literature? If it doesn't, well, okay, exploring why not, right? Is it something to do with the theory? Is it something to do with the methods? Maybe your scale or your experiment weren't sensitive enough, and you're exploring all those reasons, right? But yeah, so the idea is that you should link back to the theory and the stuff that you talked about in the introduction in your discussion section. What would you say the most important things to remember, top tips? So structure, I would say, make sure you've got very clear intro, methods, results, discussion. The intro should motivate the study. It should include the hypotheses. Top tip, the hypotheses should be explicitly linked to the literature. What we mean by that is, I've seen so many years, imagine how many reports I've had to mark, where beautiful introduction, you know, key theory and stuff, and then it's almost like, oh, and the hypotheses were this, right? Then that story needs to flow into the hypotheses and to explicitly link them to the literature. A little technique I use, obviously this is paraphrased and you can kind of change it around, is that imagine you've talked about some study of mine in the intro, and that's a key, that was a key study that led you to, or key theory, key study, key framework that led you to your hypothesis. So you want to then, when you've got to that section, you want to be like say something like, given the results or given the theory of Rhodes et al. 2023, and then a very quick recap who predicted that time perception would be different in dark versus light ambient temperature. We expect to find that blah 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 blah. Yeah? So there you're linking, you're kind of signposting back to the stuff that you've talked about, but then you're explicitly linking your hypotheses to the literature, right? Another tip about the intro and discussion is that, for me at least, the difference between kind of 2-2-2-1 and a first is that what you'll see in a first class report is that the critical evaluation, the understanding is not surface level. And what I mean by that is that a surface level analysis would be, oh, this paper found this other paper found this, and we expect to find this. That's fine, right? But it's not that first class level. it's the circuits, like this result and this result equal this result. You're missing all the theory, all the stuff that's kind of below the tip of the iceberg. So what we want to see, and what would get you into that higher grading, is that, okay, introduce a theory or a framework, right, or an idea, and then you're using key studies to highlight how that theory has been successful, you know, what it means, but what predictions come from the theory itself. Yeah? And then in your discussion section, you restate your findings, you say how it links to other studies on that topic, but then what does it mean for that theory? Does it mean that the theory is supported? What part of the theory? When you see a theory or a model, you know, there's different aspects. Be specific, be precise. Does it support a particular part of that model or theory? If it didn't, well, you know, could it be that, you know, your method, you should have found this finding? Could it be down to the method or, you know, the limitations? Or is it a real finding, right? And it has implications for the theory itself. Because if you've got a very robust method that really, really measures a part of a theory or a paper that you've read, right? Be bullish. We'll be like, yeah, no, you know, actually we use valid, reliable scales, that we used a robust method, we got the correct amount of participants, the power was high, and this theory couldn't account for our finding, right? So be bullish, don't slate your study if you don't think it needs to, right? I mean, I don't think we did completely, you know, in the space of time that we had, and, you know, doing it in class and stuff. There's going to be reasons why probably things weren't as sensitive enough as they should be. But you see what I mean? We've gone from just saying this result's the same as this result to, okay, this result's the same as this result in the context of this theory or framework or competing theories and competing frameworks. And this kind of thinking, it doesn't just apply to reports, right? This is in essays as well. Yeah? Does that make sense? Hopefully that makes sense. Oh yeah, other stuff to remember. So results section, descriptives, assumptions and tests are all included. You know, if there's a significant effect, make sure there's the post-op test or something about that in your results section. Methods are thorough, complete. Someone could pick up your report and redo it, right? Should the hypothesis be separate from the introduction, like bullet points? No. Right. Yeah, included in a sentence, included in prose, right? Not bullet points. No. Can we also yeah, you can critique existing literature. Yeah, if you think there's an issue with it, absolutely. If it's based on and you can back it up, either theoretically or how it doesn't fit into something, yeah, absolutely, you can critique it. That's the whole point. I mean, this course really shouldn't be called Statistics for Psychology. I mean, it is, obviously, but it's more like investigation. It's becoming a researcher, right? Thinking and trying to understand how the statistics map onto your understanding, but also others' understanding of the world, right? What else could I call the course? Investigative statistics. Oh, investigative statistics. Something like that. Any more questions? Hopefully this is quite useful for you, by the way. I don't mind doing these every so often. I have actually got it set up, so I've got my gaming PC here as well. So I've often thought about doing a nighttime stream to talk stats whilst getting very frustrated on the games that I play. Any other questions? But yeah, hopefully this was useful. We'll come back to OBS for a second. Any other questions? I need to listen to I've been listening to Alien Rock recently, or Alien Funk Rock. Henge. Superb. Let's put some Henge on. Any other questions? I'll give it a couple of minutes. How long should it take to complete? Like, the writing, do you mean, Jade? Like, if I was going to start a report, like, tonight, which I'm sure you've all been working on it over Christmas and the New Year. So, would you mean, like, as if I started, like, now, and I had a blank? I had my data, it was analysed, but, like, writing it up, is that what you mean? Yeah, it's the 5th. So if you've downloaded the guidebook before kind of November, it is updated on there and on the drop boxes as the 5th. They changed it. It wasn't me, because of a clash between something else being in on the 8th, but wasn't me. I have sent a lot of emails saying it's the 5th as well, just to be sure. I might send another one tonight as well. Any more questions before Jade gets back to me? Yeah, abstract about 150, 200 words. Yep. Yes, Martha? Yeah, that must be it. Yeah, I don't know. They just told me it's got to change. So I think they have a policy that you can't have like 2 assignments due on the exact same day or something. How much analysis do you think is suitable for regression? Yeah, well, like I showed you earlier, you go back. This will be. I'll post it on the KLE after this is done when it's processed. If you go back and have a look, it's essentially for regression descriptive statistics, right, for each of your variables, the correlation matrix or the correlation table, right, the R² value, which tells you how well the model fits the data, essentially. So that R². Whether it was significant or not, that's the p-value from the ANOVA there. If it is significant, if it's not significant, you stop there. Done. If it is significant, the coefficients table. So then it could be that, okay, so the question is, which of the predictors is significant? There you look at the coefficients table and the p-values. Tells you which of those. They could all be significant. It could be 1, it could be 2, it could be 3, it could be none. If you have more than one that's significant, you then look in the standardized column. Again though, if this table's in your report, you can just refer to the table, right? You don't have to keep putting the numbers, repeating the numbers. Okay, which of the standardized betas is the biggest? And that's the most important, or the one with the predictor with the most explanatory power. Okay. The assumptions. So, as I said, there's 3 things. Is the VIF less than 10 for each of the predictors? Does the residuals versus predicted plot look like equal above and below the line? That's homoscedasticity. Are the residuals normally distributed? That's the QQ plot of the residuals. Okay, that's what you need in your report for regression. For ANOVA, just for completeness and people watching this back, for ANOVA, again, descriptives, what are the means and standard deviations for each of your condition, as well as you might include the Shapiro-Wilk test there as a test of normality, of each condition having been normally distributed. Levine's test for a between subjects ANOVA, which tells you about homoscedasticity. We don't want that to be significant. If it's a repeated measures ANOVA, you're looking at sphericity. If that is violated, you need to read from the Greenhouse-Geiser row for that factor. If it's mixed, you have Levine's and sphericity, which makes it a little bit trickier. And then if the main effect is significant, then you're looking at the post hoc test to look which way round that effect is. Yeah? Yeah, so, yeah, the write-up, how long would it take? I mean, it depends, doesn't it? I mean, the speed that I would probably write one's probably different, probably slower, actually, than everyone else. I mean, you can do it in a few days, for sure, if you proper go for it. But again, I'd say 500-600 words intro. You don't want to waffle. No waffling in the intro and discussion. We want to see a clear progression of ideas, right? So I know you have covered this, but what should we write about? You don't have to write about the descriptives. You just say what they are, unless they are violated and not normally distributed. Then you would mention that they're not normally distributed. But you don't need to infer anything from the descriptives. If we're doing a multiple regression of doing a periodic, should we run a Shapiro-Wilks test and write about it? No, not needed. So the assumption of normalities for the residuals in a regression, it is not around the individual variance in each condition. So we want to see that QQ plot. I need to show. Has anyone heard about Henge? Honestly, I love them. They're so good. I'll see if I can show you on here. Can you see my screen? Oh no, you can't see it at the moment, can you? Let's go back to desktop. Look, I need to show you what they look like. Let me show you what they look. I mean, I imagine some of you are not surprised that listen to this. I mean, you can see here I have a mix of the micmacs all the way to, it's quite eclectic but very heavy normally. What have we got here? Let's go back to chatting. Any other questions? Right, I'm going to put Bill Murray on. Thank you so much for all the engagement, by the way. It does make a difference. Hopefully this was useful as well. So just let me know if you think I should do these things again. To be honest, I was thinking about just doing it, just like not for stats or anything, but just like general questions about psychology or research methods, neuroscience. Because as you probably know, I do more neuro stuff. Oh yes, we've got another Henge person. Yeah. Yeah. I've seen Electrical Boy many times, actually, before the name change as well. Bill Murray's my jam, though. Yeah. Any more questions? Oh, I should show you my guitar, shouldn't I? No, I mean, I know you're not bothered, but it's a headless Strandberg. So it's my like, oh, I love it. With the correlation, do we need the table and do we need all the graphs or just the dependent variables against you? Yeah, so put all, for the correlation, you can put all the variables, so the predicted and the outcomes. It just gives a complete picture because it might be that you see there's a relationship between some of the predictors that you weren't expecting or you were expecting. So it might give you, for example, imagine if you didn't find a relationship between your predictors and outcome, but you found a very strong relationship or between the predictors. That might tell you that your scales are actually measuring the right thing, right? So if you had, I don't know, depression as one predictor and then this would be two, but anxiety is another predictor. Imagine if they had a really high correlation between them, like 0.6 or something. That would tell you that actually, well, we know that depression and anxiety are linked, and we got that in the data, right? So that's evidence that your scales were measuring the thing that you think they were measuring. So that might make you critique the model or the previous work a little bit more. Does that make sense? I've written about previous that you're more rational. Have you? This is going for the question about 400 versus 600. Have you included kind of like a general intro, like why this is interesting? What's the general topic? A stat about that thing that you're measuring? Because that first paragraph is normally quite general and like, oh, this is interesting. Have a look again. Have a look at the best way to get better at writing with psychology is reading other people's work. I really truly believe that. In fact, I'm interested to see if this comes through on audio. Does that come through? There we go. I could just chug along to like stats. Oh yeah, I know. I mean, I just. You wouldn't think, would you? Like. So that was any Gojira fans. Gojira, French progressive metal. But as you could probably imagine, strange. I had done like a general intro, which is like so again, just have a look at the links between the sections as well, because oftentimes you can get some signposting of like, okay, so now we've discussed this, we're now going to discuss this, which can kind of help with the flow of that work, right? I haven't played Brutal Legend, but I feel like I should, to be honest. That would be good, wouldn't it? Imagine I was thinking about doing these sessions like stats, but like, you know, as I said, just making it more interactive or like gaming or something, or just to make it more, I don't know, just more appealing. Because I know a lot of you, well, not saying everyone does, but like, I mean, I know my little ones, for example, they're quite big into their digital content, right? Any more questions? Because I know I must be getting like annoying now with my keep asking, but. Any more? What's the heavies? Semester 2, you'd be glad to hear, is not me. It is the qualitative lecturer. So Alex, Jenny, Alexandra, I should say. Jenny. Who else does it? I'm not a qualitative person, so as you can imagine, yeah. I think, what am I doing second semester? I'm doing the neuroimaging and cognitive, something like that, year 2. Neuroimaging and cognitive neuroscience, something like that. If there is an inverse, yes. If there's if there's a negative relationship, but we predicted a positive, that does, yeah, exactly. It's not supported. Right. It's chugging. I think it's like nervous chugging. But I hope you've you enjoyed your time with the course with me. I try and build on it each year, trying to make it more interactive and stuff. Because I know stats isn't always everyone's favourite, but there is at least a drive to kind of to make it interesting and accessible. Like doing these, for example. Like this is all in my own time, right? Doing these streams. I'm not technically back till Monday. But I thought, well, why not? You've all been engaged and so, you know, why not do an hour or two, right? If that's it, because it's 3 o'clock now, I can't see any more questions. I'm going to go and be social with my children, unless there's any major questions. No, are we all done? Looks like it. I'm going to turn up the breakdown now so you all go. Yeah, no problem. Oh, I don't know what I'm going to go and do now, but it'll be stuff. But yeah, so good luck. Hope you all have a nice year. Like I say, if you're not doing, I think I'm doing neuro and cognitive neuroscience, so you might see me there, or third year project perhaps as well. So I'll leave you all to it. Okay. I'll catch you. I hate saying goodbye, especially when you're not talking to someone. It's like really weird. You're like, I'm talking to a screen. But yeah, I'll post this onto the when it's processed later. I'll pop it onto the KLE. Okay. So with that, I will see you all in a few weeks, probably, if I knock into you when in the building in the Dorothy Hodgkin. Okay. Cheerio, everyone. Bye bye. I'll play Brutal Legend as well.